Okay, now let's start the next topic, semiconductors. Obviously for CFSE or if any revision required, I can start again afterwards, no problem. But first let us complete the syllabus. Next is semiconductor. So semiconductor is in between the conductor and non-conductor. Conductor means there the resistance is very low, or it is very high conductivity or very low resistivity, that is a conductor. Now non-conductor means resistance is very high and semiconductor is in between, where the conductivity is medium. And what is the conductivity? Resistivity value is given. Semiconductor is a substance 10 to 4 to 0.5 micrometer. Micro, not micro. This is the ohm meter, resistance. Ohm inverse is conductance. Ohm is resistance. Ohm inverse is conductance. So in between the value, and you can find this thing for metalloid type of material, for metalloid, because metals are conductor, non-metals is non-conductor, so semiconductors will be metalloid, quite obvious. So metalloids, for example, germanium, silicon, these type of materials. Carbon, but not always. Carbon, some special cases, like for example, it may be some confusing how carbon can be a semiconductor. Yes, it can be. Fullerene, Buckminster fullerene. If it is contaminated with some metal like thallium metal, you know, thallium. So if the thallium metal is kept inside this Buckminster fullerene, the football shape structure, then it can be a semiconductor. Buckminster fullerene with thallium incorporated inside the cage, that type of structure can act as semiconductor. It is found that Buckminster fullerene or the Bucky tube, carbon nanotube, these are having lot of applications in science and engineering field, and we are exploring more and more the possibilities of application. The thing is discovered in 1995, quite old, at the University of Sussex. Okay, it was discovered long England. There is a University of Sussex. There is discovered first time that fullerene. After that, you got lot of application nowadays. Carbon nanotube, okay, nanochemistry. We'll be learning. We have in the syllabus. I have incorporated in the syllabus. Copper is a good conductor, so resistivity in 1.7 10 to the minus 8. 10 to the minus 8. Very, very low resistivity. That means conductance will be just inverse. So it will come in the range of 10 to the power 8. Ohm inverse. Very high. Whereas semiconductor value 0.6 ohm meter. So if you take inverse 1 by 0.6, it is medium. This is 9 in 10 to the power 11. This is 10 to the power 11, not 10 11. It is 10 to the power. Why? Actually, it has come down again. That I know. That's why I'm telling you. It is 10 to the power 11. So this glass material insulator, it is 9 into 10 to the power 11. This has come down. It is supposed to be as a superstate. So if I take invert 1 upon 10 to the power minus 11, so 10 to the power minus 11. So it is a very, very poor conductivity. So glass is a very good insulator. Plastic, polymer also good insulator. The copper wire is insulated by some polymer, so that we are using for wirings. Okay, and whenever wiring melt, get short circuit, because that is very much conducting material. You may be knowing there is some polymers coming nowadays. They are called conducting polymer. So that polymer also can be used as a wire instead of, because metal we are consuming in so fast rate. Maybe sometime there will be no metal left in the world. We are digging out the metal. Actually, we cannot prepare copper. Can you make copper? Can you make gold? We cannot. We are not making. We are just getting from nature. Extracting from the nature. All the metals, we are extracting from the nature. We are not making any of it. Isn't it? Lithium is a very important material, but we are not making it. We are extracting from the nature. So sometime or someday, it may happen that totally the metal is consumed and we have no more left. Now you know what people are doing? recycling, because when you just dispose the mobile, the battery is disposed and you can extract lithium from there. Lithium battery people are using, so you can extract lithium from there, because lithium is a very rare metal. Why it is so rare, can you understand? Because it is having odd atomic number. Odd atomic numbers are comparatively rare. Now semiconductor, these are the properties, three properties: resistivity, less than insulator means in between insulator and non-conductor, conductor, in between the insulator and conductor, that is the property resistivity should be there. Now semiconductor negative temperature coefficient, that means as you may raise the temperature, the resistance will decrease, and that means the conductivity will increase. At a higher temperature, the conductivity will increase. Why? Because electrons are filled into different, some bands are there. We'll be learning that different bands are there. One is called the valence band, another one is called conduction band. The valence band and conduction band for the metal, it is overlapping. That means there is no gap at all. So freely electron can flow upward. Up and down can happen anytime. But for an insulator, the gap between the conducting and non-conducting, one is the valence band and conduction band, the gap is very large. So overcoming this gap is rather very difficult, and it will need very high energy to overcome that. That is insulator. Now semiconductor, the gap is very low. So with a little bit of energy, it can overcome. So that's why if you raise the temperature, the electron can automatically jump from valence band to conduction band. That is the property of the semiconductor. Semiconductor. When a suitable metallic impurity is added, that is called doping. Suitable metal impurity. Example, if you take germanium and dope with arsenic, then germanium has valency 4 and arsenic has valency 5. Hey, why not listening? Talking. Listen. So this germanium, if you contaminate with arsenic, germanium is tetravalent and arsenic is pentavalent. So what will happen? One electron will be extra, because 4 electron is involved in bonding. So what about the fifth one? So that fifth electron will be extra. This additional electron is free of cost type, means it has no role. So it is lying freely, and that is a unpaired electron also. That's why it can freely move, and it's called metal excess. That's a defect called metal excess defect. By using this metal excess defect, we can use that as a conducting material. Semiconductor, but with doping, the semiconductor behavior can be enhanced towards conductivity. Okay. Why do we need semiconductor? Sometimes whenever we need, we want that current should flow, and when we don't need, current should not flow. That property will need. When the current will flow, if you give a signal 1, when the current will not flow, it will give the signal 0. So from that, the binary 1 and 0 will be generated, and by using that property, we can make computers, because computer is running on the bits 1 and 0, binary system. So either current will flow or current will not flow. That is the way you can make it, because in the motherboard we have lot of lines, and that microprocessor in the center, that is the head or brain of the computer, that is the chip. So what it does, it will either allow the current to flow or it will not allow the current to flow. So that is the thing, either 0 or 1. If the current flows, it will be 1, not flow, 0. There is nothing in between. So this is germanium, and this is a semiconductor, but the semiconductor properties may not be that much good. It is called intrinsic semiconductor. It has no doping yet, but if you give the doping, then it will be in extrinsic semiconductor, then it will have a better semiconductor property. Arsenic, or if you go for aluminium or boron type of doping, it will give holes. Okay, so two types of semiconductor, one is called that N type, another is called P type. So if the arsenic doping is done in germanium, then you get the N type semiconductor, because the excess electron will be there. It is called metal excess. Okay, no, not metal excess. Metal deficiency, electron is more. Okay. And if the metal is excess and electron is less, then it is called metal excess. Silicon, similar behavior like germanium. Silicon and germanium both are in the same group in the periodic table. So silicon above and germanium below. Silicon, germanium, till lead, isn't it? So this is the gap between for a semiconductor, the gap is like more or less 1 to 1.1 electron volt. That is the specific gap supposed to be there for a semiconductor. This gap should be very much specific. Conduction band and valence band gap, that is most important one. So the gap should be something around here, otherwise it cannot be a semiconductor. There should be certain gap, otherwise it will be a conductor, not semiconductor. There should be certain gap. So it is around 1 electron volt. For silicon it is 1.1. For germanium it is still smaller, 0.7 eV. Why it is decreasing? Because silicon is above and germanium is below. So as you go down in the periodic table, metallic property is increasing. So germanium is a more metallic, having more metallic property compared to silicon. That's why the band gap is decreasing. The band gap here is decreasing. It is between it is 0.7, and for silicon it was 1.1.
Which one is better?
Germanium is better.
Why?
No, germanium, no, not better. Actually, no, better to tell that. Depending on application. Silicon also has got its own application. Germanium has got its own application. I give you one example. Silicon, which one we are using maximum as a semiconductor in it is called Silicon Valley. Have you heard about Silicon Valley? Why do you call it Silicon Valley? Because the silicon is used widely as a semiconductor material into hardware industry. Into hardware industry, silicon is used widely. But germanium is also used for some specific purpose there. There are a lot of application, everywhere is not same. Silicon somewhere is best and somewhere germanium is best. Achha, now one example. Silicon wafers separated by some separator, maybe insulated plastic separator. We can make layer after layers, and then we can give some make such a material that is optically sensitive. When sunlight is falling, then current will flow. That type of material giving us what? Solar cell for calculator and all these things. Okay. Selenium metal is sometimes used. Selenium is also very good for this type of purpose. Whenever photovoltaic material, But to some more information, these things already you know. So I am telling you something new. Natural some materials has got this type of property. Have you heard about house plants? House plant जानते हो कि नहीं? House plant means that you can grow inside the house. You can keep at the window. Not lot of sunlight is not required. This artificial sunlight is also good enough for it. That type of, for example, peace lily. Okay, it has got such a property that with a little bit of light it can survive. Why? Because it can take, for photosynthesis, it can take visible light, it can accept ultraviolet light, all sorts of light. Whatever light available, it can accept. So that is the beauty of the thing. And if you can extract that material and make a coating on the surface of the silicon, it can be a very good photovoltaic material, photovoltaic cell. So this is the summary. Free electron means electricity. So we said that energy band help us to understand the current flow through a semiconductor. Okay. Effect of temperature. Just have a go through because we have very limited time. That's why I'm going fast. Absolute zero temperature. Okay. And above absolute zero temperature. Absolute zero temperature, semiconductor will behave as a non-conductor, and above absolute zero temperature it will behave like a semiconductor, and above certain temperature it will behave like a conductor. At absolute zero there will actually no current flow. The gap is good enough to resist. Above absolute zero it will behave as a semiconductor. Okay, I think I end up here because otherwise we will be late for the next class.